Question 20, a square is inscribed in a circle with radius 6 square root 2 inches. What's the perimeter of the square in inches? We always want to give ourselves a drawing to make this more concrete and less abstract. So here's our circle, and a square is inscribed in it. That means the square is inside the circle and the corners of the square are touching the circle. And the circle has a radius of 6 square root 2. So we could show the radius there, but that's not going to be very helpful in finding the perimeter of the square. So what's more helpful is to show the radius on a diagonal. So here's the center of the circle, and here's the radius, which is 6 square root 2. We're looking for the perimeter of the square, so we need the sides of the square. Well, sometimes I find it helpful to pull a drawing apart and pull a figure out. So I'm going to now focus on the square. And I know that from the center of the square to the corner is 6 square root 2. And you might see it be helpful to extend that line to make a diagonal of the square, which would be 6 rad 2 plus 6 rad 2. So the diagonal of the square is 12 square root 2. Now, of course, we know a square has right angles and all the sides are the same length. So it's helpful to recognize that this is a special triangle right here. It's a right triangle that is isosceles with two sides the same. And so these angles are 45 and 45. And in the reference information at the start of this SAT section, it lets you know that the side lengths of a 45, 45, 90 triangle are in the relationship S rad 2. So if the hypotenuse of this triangle is S rad 2 equals 12 rad 2, then we know that S is 12. So the length of the sides of the square is 12. And what are they asking? What's the perimeter? There's 4 sides. 4 times 12 is 48.